Hello and welcome back to the Over-the-Wire Natas web security wargame. Today we're going to be taking a look at level 11, and to start off here I'm just going to open up our getflag script from last time because we're going to use that to work off of as we've been doing. You can see we still have our output from the last level, so I'm just going to copy this password and change in the authentication here so we can hopefully get authenticated to Natas 11. If I run this here, it looks like it's working fine, but just so we can have a better view here, I'm going to open it in the browser. Alright, you can see we're authenticated here, and we have an HTML form, and it's asking for background color, and you can see that the default value here is white. This is basically the hexadecimal representation of white. You can see the sort of caption here is cookies are protected with XOR encryption, which sounds interesting already, but I guess for a proof of concept, we can see if this actually changes. If I just put in 6 0 characters there, that's going to be black, just to test out, and there we go. And you can see if we just put in red, for example. So it appears all this is doing is just changing the background color. But this line about the cookies sort of intrigues me, so I'm just going to hit F12 to open up the developer console here. And once that's open, I'm going to go over to storage, and then I'm going to look just under here under cookies for this web page. And if you remember from, I forget what Natas level it was, but we dealt with cookies before. I'm just going to close out these Google Analytics ones. But you can see here this data cookie is something that we're not typically used to seeing. You can see a strange value here. I might have to zoom out to read the whole thing. You know what I'll do is just copy this value and bring it over to Sublime Text in a comment. And you can see it's quite a long string. It looks like the end of it here, this is sort of URL encoded, so we might need to unencode that just so we can get the proper value, which I'll do. I believe CyberChef can do that quite quickly. If you haven't heard of CyberChef, it's a great tool for doing all sorts of encoding and decoding magic. You can see it's a Swiss Army knife for web app encryption, encoding, and compressing. You caught the whole description there. But basically, if we load up CyberChef, all I'm going to do here is just paste in that value, and then if I just do a search for URL decode, there we go, drag that over to under recipe here, we are getting the proper value, which kind of looks like base 64, as seen by this equal sign, which is typically used for padding at the end of base 64 strings. So we're just going to copy this apparently actual value here and bring it over to our script. So there we go. I don't think we're going to get anything of value if I echo this out to base 64. TAC D, and if anything that just looks even more confusing, but it is seemingly in ASCII text, so it looks like that was base something, but it might be double encoded or triple encoded or something. We might need to dig into the source code to find out in more detail, which we will definitely do by going back to the web page here. I'm just going to change that back to white because it was bugging me. But then we're going to open the view source code page in a new tab here and take a look at the PHP. So the most interesting thing I see is this sort of logic near the bottom of the source code here. And basically, if we're looking at this, if data, and then there's a show password parameter, if that's set to yes, then seemingly we're going to get the password printed to the screen. And obviously this is going to be our goal here to sort of make this value yes or true in order to get the password printed out. You can see here data is set to the load data function with the default data sort of parameter set. And if we go up, you can see the default data is set to a PHP array. And we can see here show password is set to no, and the background color is set to all white, which seemingly is the case if we just refresh the page. This seems to be the default data. Okay, so we have the default values here, but how can we actually manipulate the data here and sort of manipulate this array to change the value here to yes? So if we break this down more, you can see the data value is being extracted from our cookies. So if we have that data cookie set, which we do by default, so that's being base 64 decoded, obviously, so that makes sense. So this is sort of where we're at now. And then we can see an XOR encrypt function is being run on this string. And then after that, basically the return of this function is sort of being JSON decoded, seemingly into a proper array. But I guess we can break that down some more. So if we infer a little bit here, it's likely the case that this temp data variable is going to equal this at this point, so this PHP array, because you can see the next if statements here are basically looping through or sort of searching through this array to look for certain keys that exist. So you can see show password, and then it's checking to make sure that background color key exists as well. Then it looks like it's doing some preg match or regex on the background color array just to make sure it's in proper format for hexadecimal. And then that's sort of being set to a variable named data, which is being called in this logic here to basically reveal the password, yes or no, if that value is set. So kind of convoluted here. And the other major function that we didn't cover yet is going to be this XOR encrypt function, which obviously was called here after we base64 decode the value of our cookie, which we've already done actually in Sublime Text. So we're basically at this stage now where it's taking in our parameter here, which is going to be that value. So there's going to be a key, which we can't see. It's been censored. The text, or the, I guess, plain text in this case, because this is an encryption algorithm, is going to be whatever we input. And the out text, or likely the ciphertext, has not been set. And that's probably what's going to be set in the return of this function. Yeah, so you can see we have the out text or the ciphertext there. That's going to be returned whenever this function is called. And what's basically happening here in this function is it's iterating through each character in our input, or our, base64 decoded data. And for each character, basically, it's going to be running an XOR or an exclusive OR operation, depending on the length of the key. And the length of the key is sort of repeated to match the length of the input, which I might get into a bit later, but that's actually a vulnerability. It makes it a lot easier to identify what the key is going to be. But other than that, I think we've pretty much covered the script here. Like I said, it's kind of convoluted, but essentially the web server is taking a cookie from our request. It's sort of deserializing it or breaking it down using those decode functions, going to be running this encryption algorithm on it. And assuming the output of this, or the ciphertext, is going to be a JSON encoded object or array. And then that sort of gets decoded into a PHP array. And the logic of the web server is going to be using these values to basically show the password if this is set to yes. So it's kind of a deserializing attack if we start thinking about what we can do here. And I will say this level kind of steps it up, especially if you're not familiar with XOR encryption, which I wasn't at the time of doing this level. And I guess the first thing I should do is sort of explain what XOR encryption is in the best way that I can. I'm not an expert on this, but it's sort of based on my research. What I understand is the way it basically works. So when you think about the XOR encryption algorithm, it performs an exclusive OR operation between each character in a message, so your input or your plain text, and it uses a key to basically produce the encrypted message or the ciphertext. And the XOR operation itself is kind of a mathematical operation that deals with bits. So basically compares two sets of bits, one being the key and one being the input or plain text in this case, and it will return a 1 for each bit if the two bits that are being compared are different, and it will return a 0 if they're the same. So if you think about the different steps, so it's going to convert this plain text message into the binary format, obviously because it works at that sort of bit level. It's going to perform the exclusive OR operation between each bit or each character in the binary message, and then it's going to basically convert the resulting binary message or the ciphertext into a more readable format like ASCII or UTF-8, and that's essentially going to be the encrypted message. So when you break it down like that, you can sort of see that the XOR encryption is relatively simple, and it's kind of a weak form of encryption, and it shouldn't be relied on for any, production stuff or securing sensitive information. But it is kind of the foundation of what more robust encryption algorithms like AES or RSA are built upon. So to sort of walk this through in a more meaningful way here, I'll just make a simple file here that I can use to sort of demonstrate. So when you think about different comparative operators in mathematics, for example, you have AND, you have OR, and in this case, you have the exclusive OR the XOR. So if you have experience with basically any programming language, you've probably seen ANDs and ORs being used in the past. And in fact, we've sort of used this in some of these examples or some of these levels as well. If you think of AND and sort of how the AND operation works. So with AND, basically, let me see if I can zoom in some more here. So when you think about comparing things with AND, you're going to have two things you're comparing against. And in the case of AND, both of them have to be true. So, if you're running a Boolean operation on both inputs and, one returns false and the other returns false, well, obviously that's going to be false because both have to be true. If the first one returns true and the second one returns false, well, that's still going to be false because they both need to be true. And obviously to beat a dead horse here, if both are true, well, then it's going to be true. So when we think of OR, well, it's kind of different than AND. Only one has to be true. So in the same case, first one false, second one false, still going to be false. First one true, second one false, well then it's actually going to be true because only one of them, in this case the first one, was true. And then in the third example where both are true, well that's still going to be true because only one has to be true. If they're both true, that's fine. It's still going to be true. But now we sort of get into the exclusive OR, and in that case, it's kind of different in the sense that, so I'm just going to put XOR here. So in this case, only one can be true. Maybe I should have worded this better because you're probably thinking, well, how is that different than OR? Only one can be true. Well, it's kind of exclusive in the sense that, why don't we just do an example? Same type of thing. First one false, second one false. Well, that's going to be false. Because they're both set to false. But in the second example here, where the first one is true, second one is false, well, it's going to be true because only one of them can be true. In the third example, if both are true, well, it's actually going to be false because only one of them can be true. In the case of OR, if you remember, it doesn't matter if both of them are true, it's still going to be true because only one has to be true. Said true a lot there. But in the case of XOR, it's exclusive, so only one of the values can be true. And that's sort of how we can get this encryption algorithm type of operation where it can be reversible with a symmetric key. But just to sort of drive this point home even more, let's say we have a fourth example here where the first value is false and the first ends up being true. Well, that's also going to be true just like in this case because it's exclusive. Only the second value here is true. So hopefully that makes it more clear, but you might be thinking, how is this relevant? How is this being used in that PHP function we looked at to sort of do an encryption? Well, let's sort of think of it at the byte level. So let's say we have our two values. One will be the plain text, and the second will be the key that we'll use. So we'll break it down to bits, just as the XOR function does. So let's say for one, this is going to be our plain text. So let's just give it 5 bits of random, ones and zeros. This is binary. Let me just say plain text, or our input, that's going to be our plain text here. And for 2, this is going to be our key. And so let's just give it a random key, and that will be our key. Let me just move this up a bit. So you see we have two different parts here. We have our plain text and our key. And basically, if we use our XOR encrypt on these two values here, well, we're going to get a third value. Third value is going to be our encrypted or our ciphertext. So we just put 3 here for our ciphertext. So we can basically manually XOR encrypt this. So if we think about the rules here, where only one can be true, well, if we think about the first value here, so we're going to be comparing, 1 to 1, 1 to 0, 0 to 1 here. So if you think about the first character here, well, they're both true because in binary, 1 is going to be true, 0 is going to be false. So in this case, they're both set to true. So the resulting value of our XOR, or exclusive OR, is going to be 0. So let's move on to the next one. Well, 1 is true and 0 is false. So that's sort of an exclusive OR here. That's going to be a 1. So same thing for the third value here. First one false, second one true. Well, you can see that's going to be true. Same thing for the fourth value and the fifth value. So that's going to be our ciphertext. And obviously this is a very simple explanation of it. We're doing 5 bits here, but you can sort of see the concept and how it works. It's taking these two values, it's performing this XOR or exclusive OR mathematics on it, and we're getting a resulting value from those two values, which is going to be the ciphertext in this case. And why do I keep saying in this case? Well, because it's reversible. This key is a symmetric or a shared key, basically, that we can kind of do the opposite and do the reverse here, where we're providing the ciphertext and the key, and our result is going to be the plain text. So how does that work? Well, let's do the same thing again. When you receive the ciphertext, you don't have to use a different encryption algorithm to decrypt it. Like I said, it's a symmetrically shared key, and instead of using XOR for the plain text, we're just going to XOR encrypt the ciphertext. So we have 0, 1, 1, 1, 1. And again, ciphertext. And that's why I kept saying in this case, because in this first case here, we were encrypting the plain text. In this case, we're going to be decrypting, or technically encrypting again. It doesn't really matter how you say it. We're going to be decrypting the ciphertext. So for 2, that's going to be our key. Same thing. So let's walk through the exclusive OR operations again. 0, 1, well, that's going to be a 1. 1, 0, that's going to be a 1 as well. It's true. 1 and 1, both true. Well, that's going to be false. 1 and 0, well, that's true. And 1 and 1, that's false. So what is this? What is our value here? We have 1, 1, 0, 1, 0. Well, we have 1, 1, 0, 1, 0 up here. That's our plain text, which you can see was the result of putting our ciphertext through our key. So hopefully that makes things more clear, I remember when I sort of came across this conclusion, things started to make sense to me even at this simple level here. So, and as simple as it is at the sort of mathematics level, it can be quite a tricky thing to sort of get the hang on at a grander scale. I'll put some links in the description below, basically to read up or watch some very good content that will teach you more than I could sort of give it justice here. But basically that sort of wraps up what I wanted to cover here. You can see we're back to our original value. So in this challenge, if you remember in the PHP source code here, we have our XOR encrypt function. And we can see the 3 values here. So the key, we have the text or the input, which is going to be our plain text or ciphertext, depending on which order you do it in. And we have our out text, which in this case is the ciphertext. But now we need to think about what these values are, because we're going to need to figure out the third one. Well, we're going to need to figure out all of them. But in this case, so if you think about what is going to be the text variable here, well, let's look back to this load data function. We have our data cookie being base64 decoded, and then it's being sent to the XOR encrypt as the in variable here, which is then set to the text variable. So we can safely assume this text variable here, or our plain text, is going to be, our cookie value after being base64 decoded. So that's going to be this value here. This is our base 64. All we need to do basically is to decode this now. And again, we'll echo, send that to base 64 tac D to decode, and we'll just copy this value. And we can basically save this as our plain text. Okay, so let's go back here. We don't have the key, that's been censored. Now what about the out text or the ciphertext? So if you remember what happens to the data cookie here, it goes through this decoding and encryption and more decoding, and it gets sent to temp data, which then eventually kind of gets extracted out into a PHP array, and you can see we're getting values from the PHP array here, and that's what's being used to control the logic in the application. So we can safely assume, in this case, that the ciphertext is going to be this PHP array here, because that's the default value, and we're using the default cookie. So if the default cookie goes through the XOR encryption, well, the output is going to be this array. But not so fast because it gets JSON decoded. So the actual ciphertext we're going to want to input is this value, but JSON encoded. So all we would really need to do to get this ciphertext value is copy the array here and then just JSON encode this, right? Because if we're doing it backwards, well, it gets JSON decoded. So if we encode it, we should have valid, a valid JSON object containing these values. So if you remember, we can run PHP in the command line basically if we have it installed. So I'm just going to call this JSON encode.php. So if we just set a variable named array, so we paste in our array here, now we have it as a variable. And all we need to do now is just print JSON encode, then just pass in our array. And that looks good to me. So if we run PHP on JSON encode, might have just forgotten the semicolons. Let me try that again. Oh, there we go. Okay, yeah. So it looks like we have a valid JSON array now, or a JSON encoded array based on what we started with. So I'm just going to copy this, paste it into our handy Sublime text file here, just so we have it. So let's think now. We have our input, which is going to be our default cookie. We have our output, or our ciphertext, which is going to be our encoded array. So we can basically, if you think about it, we only need 2 out of 3 of these parts. So, for our first one, if we have the plain text and we have the ciphertext, well then for the key, well, we can just run our XOR operation. Well, that's exclusive, yes, false, true, false, and true. Well, that's our key value. So if this isn't clear, we are able to get our key value if we just have the 2 parts, the plain text and the ciphertext. It's completely reversible in that way. We just need 2 parts, and we can sort of infer or make out the third part using our XOR encryption here. So with that said, we basically have all we need now. So let's do that. Let's copy this function. Let's just create decrypt.php, paste that in, and now we need to start filling in these values. If you think about it, we can just change these sort of values here. So instead of out text, we're just going to call that key because we don't know the key. For this first value here, we'll call it plain text. We'll set that to the in argument. For text, we'll call this ciphertext, and this is going to be our string. I'm just going to open this in Sublime Text because it was very annoying to work with. If we change the build profile here to PHP, we should be able to run this. And then just make sure we have PHP going on here. Okay, so let's make this clearer. Let's set the same array variable to the PHP array. Just set ciphertext there to array. We're going to have our input when we run the actual function, and then we should get the key. So let's try that. Instead of printing test, well, let's print out the return value of XOR encrypt. We also want to make sure that we're running JSON encode on our ciphertext there, just so we're getting that same JSON encoded string. And then for our input, well, remember we want to base 64 decode this, and I apparently didn't save that output there. So I'll just run that again, base 64 tac D, and I'm going to copy the output. I'll just call that plain as a variable, and then we'll paste that in. Perfect. And all we need to do is just provide that plain variable as our input here, and we should be good. Let's run that. And I'm always forgetting these semicolons. And that's why I shouldn't have renamed these, because it sort of affects the rest of the function here. Obviously, I don't know what I was thinking. So let's change these back. It's not really going to make sense if you're thinking about it at a theoretical level, but this should still work. Okay, let's try that. Okay, there we go. So that ran. Yeah, that was sort of just scratching my head there, realizing, yeah, I shouldn't have changed the name of those variables. Anyways, we got an output here. What is this? Well, you can see KNHL, KNHL. It looks to be a repeating pattern of 4 characters. And if we think about what happened, well, that's the output of our ciphertext and plaintext going together. Well, it looks like this is our key. So this relates to what I was saying earlier near the start of the video, in that this is sort of a more vulnerable setup of a XOR encryption algorithm, because in this case, what it's doing here is this, with this for loop, is it's basically iterating through each character in our input and sort of extending this key, or extending this 4-character key here to sort of match the length of the input. So because of that, our key is quite short with 4 characters. That's a very weak key. It can quite easily be brute forced in that case, which is why you always want to have a long key, and more robust encryption algorithms have extremely long keys. But obviously, to make this challenge more easy for us, we just have a 4 character repeating key here. But anyways, we can now sort of use this to our advantage. We have the key, and we can sort of set whatever we want as the plain text or the input. And in this case, we can change the array to whatever we want. So let's sort of make a duplicate of this file here and open it again. And we'll call it encrypt because we're going to be sort of reversing this. So what do we need to change here? Well, let's look back at the source code. In this case, the key is censored. Well, we have the key now. So let's change the key to KNHL, which is the repeating key. So now we have the key filled out. We have the text, and we're getting the output text. All we need to do is basically just change our array. That's sort of why I set it up in this way. So all we need to do to sort of bypass the logic, if you remember, we change this to yes. And just to sort of make it more visual, let's change this to red. So let's run this with Control B. And you can see we're getting an output here. Let me drag this. And you can see we're getting an output here. So let's copy this output. I'm going to go back to our getFlag script and paste this in. So if we think about doing this backwards, we ran our JSON encode for our input. We ran our XOR encrypt. And now we just need to base64 encode it and set it as the value of the data cookie. Well, let's try that. And for fun, let's just use CyberChef again. Paste in our input, and then we'll just do 2 base64 here. And you can see we are getting base64 output, which kind of looks, well, we can't really tell if this is correct, but it kind of looks similar to what we originally received as our cookie. And with this copied, we're basically ready to test our exploit. So let's do it in the browser because, again, this is going to be more visual. I'm going to open the developer console again. I'm going to go under storage, under cookies. You can see our original, whoops, I zoomed in way too much there. You can see our original data cookie is set to that value. Well, let's change this by pasting in our new value. Hit enter. You can see it was changed there. And let's just refresh the page. Okay, awesome. It looks like something didn't really go right with our background color, whatever. But you can see we're getting the password. So that is the password there. And the reason why is because in our cookie, show password equals yes. Once it's sort of deserialized, de-encoded, ran through the encryption algorithm again. But then on the web server's end, it's sort of building that array back, that PHP array. It's seeing the value of show password is set to yes. So that was it. I mean, let's go back to our getFlag script and sort of input that as our cookie. So we don't need any of these comments. Let's just copy our exploit cookie payload there. So let's just set a cookie variable as a Python dictionary to use in our request. So again, cookie name is going to be data, and then the value, we're just going to copy this here again and paste that in. We're going to set cookie to equal cookie, and we should be good. Make this a bit wider here. I'll turn on word wrap again. And of course, I need to change the build system because for some reason it doesn't do that automatically. And we'll run again. Cookies with a plural. Yeah, it's cookies, not cookie. Let's run that again. And there we go. So, okay, so we're getting the password, finally. We didn't mess that up too bad. So you can see the password for Natas 12, and all we need to do now is just extract this, which should be relatively simple. So you can see it ends in that break tag, that HTML break tag there. So that's what we'll do to close it out. For the beginning, we'll just do password Natas 12. Okay, perfect. We're getting the password just as intended, using our regex there. And all we need to do now is just test. Okay, so let's just run Python again on our get flag, send that out to Natas 11, and we'll just run natas.sh for Natas 12. We'll cut out our Natas 11 file, hit enter, and perfect. Looks like we're authenticated. The next level seemingly has something to do with file upload. Maybe we're going to be exploiting some image file upload vulnerabilities, so that sounds like fun. I think I need to take a break after this one, though, so I will see you in the next video, whenever that is. It'll be soon. So thanks again for watching, and take care.